Hello to a new episode of Marketing4Waste podcast and live on LinkedIn. And we are here in this new episode to talk about a very important topic because some maybe 1 week ago, 2 weeks ago, I purchased a magazine, a copy of National Geographic that was totally focused on rare earths and rare elements on our planet. And inside there is a very interesting and amazing article, totally dedicated and focused on what's happening on our planet in terms of rare elements and their use on the environmental sustainability business, because that's what is really happening in our planet. And due to that, I started to make some research about these elements, but especially about the people that was inside the article. And I found one of the most important editors of this article, and I decided to invite here with us John Morris Pereira, that is a geologist. And welcome to John Morris Pereira. Hi, John. How are you?
Hello, Samuel. Thank you for the invitation and the credits.
It's my pleasure, and welcome to Marketing4Waste podcast. I decided, guys, to invite John Morris Pereira, that is a geologist and is one of the most interesting geologists that participated in this article, because I liked it a lot his point of view. But before to go ahead, I want to ask John to introduce himself, telling us about his history and at the same time why you decide to become a geologist, because that's very interesting. You're free to talk, John.
Okay, so that's always a big question: how someone becomes a geologist. That's well, in my early studies, I was not actually focused on the geology itself. I was very focused on nature, so that started from there. So I am John. I'm John Morris. I'm a geologist. I work in this industry already for 20 years, and I've been involved in several exploration projects and mining activities in Portugal and abroad. But my key is to keep track of mineral resources as detailed as possible in order to explore or extract them in a sustainable way. So because my beginning in this industry was related with nature, and I became a geologist because I was a caver in my young age. So I was somehow connected with the rocks, somehow connected with the undergrounds, and that was what made me look for the geology. While in the course, as you can imagine, geology has a multiple possibility of becoming some kind of geologist, a volcanologist or mineralogist. And I ended up becoming a mineral resource geologist. I ended with the experience becoming a neurogeologist, which is a qualified person that estimates geologic models in order to transform them into mineral resources that one day can be mined. So with all this activity and with the care for the environment, I became aware that there are some small things that can be done that will improve a lot the mineral industry. And in fact, a lot has been done in the last 10 years in this area. And there's a huge difference from what people think the mining industry was in the 1950s, for instance, and what the mineral resource and the mining industry is today regarding to waste management.
Great. And Thanks a lot, because that's very, very, very important, because you started from nature, and we in this podcast we talked several times about the importance of nature, and the the idea that there is behind waste management. It is now becoming circular, but it starts from nature, because nature is the great example of circularity for the planet, for all the humanity, because that's one of the most important point. And starting from what you said, there is I would like to go direct to the point, because we listened last year, and not only last year, about several shortages of some materials across the planet, and especially talking about rare earths, and especially talking about lithium, cobalt, and a lot of trouble that at the same time these troubles in terms of the different areas of the production, but a lot of ideas appear in the market, because also in our podcast we talked about recycling a lot of time, the importance of recycling, especially some goods and items like smartphones, like LCD, like cars and batteries, to solve and to reduce this shortage. But going in a different point of view, and watching the situation from a different point of view, could you give us your overview about lithium, rare earths, and the availability, first of all, but also the possibility to use in a different way the resources that we have, that we are mining in this period?
So the history behind mineral resources, since man started mining them or using them for his profit, it has a direct relation with its need. So when we extract mineral resources and we process them into our utilities and houses and roads and airplanes and all sorts of equipment and constructions, we are taking from the nature, we are using a certain mass of those metals or rocks. In the beginning was stone for the Stone Age, and then all the way the history brought us into the Industrial Revolution, where coal and iron and copper, everything was important, and we were mining everything, and not really aware that mining has a high level of impact. And this was the mid-century, the past mid-century. At the moment, we are looking to, in the last 10 years or 15 years, we are changing. So the mentality is changing, and we are needing different products that were never mined in the past at this level, or at least with the mass that is required to change some habits that we have, to change some industries that we have, and going to the word that everyone uses, the electrical transition or decarbonization or whatever people wants to tell. At this stage, what we know is that humanity and its economic infrastructure has a deficit of lithium, cobalt, and vanadium, and rare earths, and iron, to be able to build what they have, or what they have in plans to have. So meaning electric vehicles, grid storage facilities, more effective ways to store energy that is produced, that is not consumed, like in the solar energy and the wind, most renewable intermittent sources. So what is happening right now is that we don't have enough metals extracted from the nature that even if we can recycle 100% of those metals that are available, we will be covering maybe 10% of the needs that we have to make that change. So at this first stage, it's going to have a significant impact on nature, because we will have to mine those. But those resources are resources that have a high level of potential in the future to be recycled, to be reused, as opposed, for instance, to the oil industry and to the gas, which once we burn it, we only can envisage to capture the water they produce and the carbon dioxide and do something with it. So in this case, even if the recycling technology and the reuse technology is not perfect at this stage, it's increasing dramatically as it is the plans to change things in terms of energy. So the need is right now. So in the next 10 to 15 years, we will need to find and explore and extract the most sustainable mineral resources that can provide these metals or these materials for us to build the solar panels, to build the windmills or the aeolian generators or the EVs, the electric vehicles, because everything turns around the EVs, but it's not just that. So we need rare earths to have all the magnetic infrastructure for a wind farm. So it's tons and tons and tons of rare earths that are necessary. So
wow.
my main outcome on this long speech is that we really need to bring these metals into the industry to be able to manage them in the future. Yeah.
Great. It's very interesting what you said, because it seems that the transition to the sustainable production of energies, it costs a lot, because it's very impactful on our environment and on our. It seems very impactful on the environment. At the same time, and due to that, I will ask you if you share with us which are the issues that the mining industries is facing in terms of waste management, and how it's facing them, because due to the needs of tons and tons of materials, minerals for the production of sustainable goods. Let me call them in this way. It seems that we have to be very impactful on the environment, but at the same time we have tons and tons of materials that are obtained from the mining process, and how the mining industry is facing this problem, if we can call them, if we can call it as a problem.
Okay, in some cases we are talking about problems, so things that are actually waste and are not suitable for the moment for being used on any other application. But what's happening, and it's happening intensely in the last 10 or 20 years, is that the mining industry realized that any effort they do in regards to sustainability, it has a direct action on its operational costs. It has usually dropping the operational cost, because it increases you a little bit on the effort on planning, but it will reduce significantly the amount of work that is done unnecessary. One example is the use of explosives. In the past, it was very common to see blasts of high energy and rocks flying away. And this is something that is less common, because when you do that, you lose energy in the blast. So if you lose energy, you lose efficiency. So you are using too much explosives, so you are spending money. So this is an example of how energy and effort of the mining industry is pro to environment and this on its own benefit. And a lot of things work that way. In the case specifically, in the case of of the new, let's call it the new mineral resources that are needed, which are the battery related and the transition energy related minerals. There are two different groups of those minerals. The ones that are related with lithium, more like lithium and tantalum and niobium, which can be associated with rocks that the host itself of the mineralization, it has application in other industries, such as the ceramic industry, the glass, the production of glass. So the geologic structure where the mineralization is not fully is not a waste. It's a product. Okay, it may not have a market locally, a market that can be where you can sell the product, but it's a product. So if you store it somewhere close to your operation, in the future you may have enough volume to justify having a ceramic or a glass infrastructure there to use that resource. Then you have other mineralizations like rare earths and cobalt that usually are in host in geologic formation that in low concentration, which require a high level of processing and both mechanic and chemical processing to be able to recover those metals. And there is where you produce a lot of waste that in some cases it's quite hazardous. So these are the two main differences on these new, let's call it new minerals or the energy minerals. And you have a third mineral waste or waste from the mining industry directly from the extraction and processing, which is the actual waste, because to get to the ore, you sometimes have to mine that let's call it barren rock that doesn't carry anything, where in some places it may have some degree of hazardous, in other cases it doesn't. So you need to classify them independently. And thankfully in Europe, we have a very detailed and strict law regarding the classification of waste from the mining industry. In Portugal, we have a degree of law exclusively just for that purpose. So you know exactly what you have to do. And to be classified as inert, the waste needs to be in a very tight line of range of certain contaminants, mostly acid drainage capacity and metal content. So the mining industry, what is doing is that they are planning their excavation so in detail that they minimize these volumes. Then upstream, in the past, the waste was piled in piles. Today, you only pile it randomly in piles if the waste is an inert, if it is a rock that doesn't carry the capacity to drain acid or to release metals into the environment. And here we are talking about bulk rock that is just open to access way. So if you are accessing way in a rock that has drainage capacity or acid drainage capacity, you have the legislation that tells you you need to align your waste infrastructure, you need to have it protected and monitored. So having this in place, you have those materials secured. Unfortunately, it only happens that most of the time, those rocks are not actually useful for anything, especially if they have those small bits and pieces that makes the rock or the waste not inert. When you are talking about waste from the processing, and that has chemicals and that has remains of ore, which is not 100% recoverable anywhere, you are talking about a waste that is classified, that most likely will end up in a facility that is contained and monitored and have all the rules to protect the nature from any spillage. It has contention measures. So the thing is, the legislation is there. the requirements, the technical requirements, and the best available techniques, they exist. You have several operations in Europe working within those standards, and they just really need to be strictly monitored by the governmental agencies to make sure that the installation is built according to rules. That's the first one.
That's amazing, and that's also very, very, very important, because first of all, create a group of waste that it is treated following some rules. The question that I have, and that is connected with the market, is only how many, did you know, how many facilities or many companies are available in the European market? How many companies are able, to treat this kind of waste?
Well, in the mining industry, things do not work as in the scrap metal or as in the plastic or the glass. In some cases, you have centers that collect glass and process it. At this stage in the mining industry, the processing of these products is done by the mine. So it's the mine itself that has the responsibility of, because it has an actual responsibility by law to do the operation of the waste management facilities. So it is the responsibility of those companies. What can happen if we are looking at the waste that comes for driving access to the ore? If we are talking about waste that is produced outside in the processing facility, so the company usually, its industrial process as is included, the management of waste, of mining waste, is included in all the flow sheet of the project. The only thing that, in the case, for instance, of lithium and tin and tantalum, when we are talking about rocks which has future application, what can happen is that you have when the lithium mines with production of concentrate open in Iberia, for instance, where most of the resources are in Europe. When you have your facilities that are producing concentrate, the waste, not the waste, but the byproducts of the production of that concentrate, it's a mineral, it's a rock, it's a mineral product that can be used for the ceramic industry. And at the end, it may be purchased by companies that manage that product in order to produce their own pastes, for instance, for the ceramic industry. There's a big market of factories that they don't produce the ceramic and they don't mine the ore. They just buy different products, and then they produce their own paste for the ceramic industry. And that is, but I would not call that residue or waste management. That's something in between, because that product becomes a waste if you don't have a market for it. Or it becomes a resource that is stored in an installation, but that installation will be regulated by law as a waste facility.
Okay, great. That's very interesting, because talking about the sustainability and about the process and circularity, it seems that in the common sense, there is the idea that mining is only something that generates waste and troubles to our planet. But as you said, no, it's not true. That's not true, and that's very, very, very important. And for that reason, I call it the episode "The Importance of Mining to Save the Planet," because it's guys, what John said us is that the process nowadays is not the process that we can think about. That was maybe presented and introduced in some movies, old movies, but is nothing connected to that. Nowadays, it's a high technological process that save each grams of product, metal, iron, rocks, and that's very, very important. John, thanks a lot for your time, your presentation, and everything. It's a great pleasure. Please, if you want to share your contacts here, you can do it. And after I put also on the footer of the event. And
I'm happy to share my contacts in the credits. Yeah, no problem. Yeah.
And thanks a lot for your time. Thanks a lot for your very detailed and great presentation. And
thank you.
It was a great pleasure for me, and I'm sure that it will be also a great pleasure for our listeners. And guys, see you in some weeks. Take care of you. Thanks a lot, John. Thank you.
Thank you very much, Samuel. Thank you.
You're welcome.